All right, today we're going to do a little bit more with right triangle trig, and then you'll have some more practice to make sure you're good with SOHCAHTOA. Let's write down what that is. Okay, so sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So today we're going to solve some bigger triangles. They're going to be a little bit more involved, but we're still going to be solving for x like we did yesterday. So we're still going to be looking for maybe an angle or a side value, a side length of a triangle value. So let's look at this triangle. So definitely different than the ones we did yesterday, but I still can break it down. When I'm doing these, you want to see what you have. That way you can know which trig function to use. And you also want to start with probably the triangle that has the most information in it. That way you can work with it. So I know I'm looking for x, but I also know that I don't know. I can find these angle measures. I could, but I probably need to jump over here and find some different values over here. Because if I start over here, I don't have enough information to use sine, cosine, or tangent. I just don't have enough information to do that just yet. So let's come over here and let's label some different parts of the triangle. We might need them, we might not need them, but we'll just start where there. So if this is 90 and this is 39 degrees, we can do some simple math. We can add these together, subtract from 180, and that'll give me this missing angle in this corner here. So 39 plus 90, subtract that from 180, that gives me 51 degrees. So I'm going to label this as 51 degrees. All right, let's see what else we can do. I know that this is a right angle, so I'm going to put that in there. I know that if this is 90, this is 60, that leaves space if I subtract from 180 for this to be 30 degrees. So I'm actually going to start with this triangle, perhaps find the length of this dotted line here, and then I'm going to go from there. So if I use the first triangle, I'm going to set up a tangent relationship in this first triangle. So the one that I outlined in red, I'm going to set up a tangent relationship for that. So I'm going to say tangent of 51 degrees is equal to the opposite over the adjacent. So if this is 51 degrees, my opposite side is 38. And my adjacent side, we don't know what it is. It's this dashed line here. So we do not know what it is. So I'm going to say that that is side. We're already using x. Let's use another variable. I'm going to say y. So let's go through that again. I used this triangle because it seemed like I had more information. So we're going to have to do multiple steps with this, but we're just going to baby step our way through it. I knew I had enough to do tangent because I had the opposite side and I had an angle, and I'm going to find this side of the triangle here. This side of the triangle will help me find the side length x in the other triangle. So if I solve this, the opposite of dividing by y is to multiply both sides by y. And the opposite of multiplying both sides by y, so this is y times the tangent of 51. We're going to divide both sides. So that gives me y equals 38 divided by the tangent of 51. Make sure your Desmos is in degrees as we talked about yesterday. Type that in, and I got 30.77. So I got 30.77. All right, so that gives me the length of this dotted line here. So I'm going to write that sideways because that gives me the length of this. This is 30.77. Now, that should help me. I should have enough information to now find the rest of the things that I need to find what x is. So this was step 1, and I'm going to come over here for step 2. So we just went through this step 1. Now we're going to have to do another relationship to find what x is. So let's see what I can do for x. I know that I have some different angles here. I know that I now have the opposite side, which is 30.77. We just found that. And I also know that x is the hypotenuse. So which one deals with opposite and hypotenuse? That's going to be sine. So I can set up a sine relationship. So the sine of 60 is equal to the opposite side, which we just found, 30.77, divided by the hypotenuse, and I know it's the hypotenuse because it's across from my right angle, and that is x. Now, this was not the only relationship that we could do. So I also could have done, I got 30 degrees up here. I could have done opposite and hypotenuse there, but I don't have enough information for that. I could have done a cosine for this because I have an adjacent and hypotenuse. So there's some different ones that you could do. Just make sure you have at least two pieces of information that you need. So I go through and I solve this. The opposite of dividing by x is to multiply both sides by x. And then the opposite of multiplying by the sine of 60 is to divide. So this gives me x equals 30.77 divided by the sine of 60. And we typed that in decimals, and I got 35.53. 35.53. So that means the length of x, which is what we're looking for, is 35.53. So let's recap. We were looking for x, but as the problem was, I didn't have quite enough information in this triangle to figure out automatically what x was. So I used some information in the red triangle to find a missing side. That way I can use that missing side to help me with the other triangle. So that was my strategy in solving this. Let's try another one. Okay, so let's look over here and let's write our acronym at the top. All right, let's see what we can do first. I like to just go ahead and put in my angle values just so that kind of helps me feel like I'm completing some of the puzzle that I'm missing here. So if this is 90 degrees, this is 40 degrees, I can add these together and subtract from 180. So this gives me 50 degrees. So this angle here is 50 degrees. I'm going to do the same thing on the other side. I know that this is a right angle, so this is a right angle. So we'll draw our 90-degree marking. So 90 plus 35, subtract that number from 180, and I got 55. All right, so just filling in some information here. So let's see what I want to start with. Again, if I know I'm looking for this whole thing here, we might have to do more than one relationship. I'm actually going to break this up into two separate triangles. So let's see here. I'm going to find this piece here in the red. Then I'm going to go through and find this piece here in the green. And then I'm going to add those two together because I'm looking for the whole entire length here. So x this time is the whole entire length. So I'm going to break it up into two triangles. And I'm going to call this side here in the red, I'm going to say that's going to be y. And I'm going to call this side here in the green, I'm going to say that's z. And then I'm going to add those two together. So I'm looking for the whole entire thing, breaking it up into two pieces, and I'm going to add them together. So let's start with the red. Let's see what information I have here. If I use 50 degrees, it looks like I have the opposite side. So this is 50 degrees, go directly across from that. That's going to be 500. So I have the opposite side. That's good. And I don't know what this side here is, but I can solve it. So let's use tangent because tangent deals with opposite and adjacent. So the tangent of 50 degrees is equal to our opposite side, which is 500, over the adjacent side, which is y. All right, we're going to go through, we're going to solve this. Opposite of dividing by y is to multiply. So y tangent 50 is equal to 500. The opposite of multiplying is to divide. So y equals 500 divided by the tangent of 50. So we just solved our equation. So I set up tangent is opposite over adjacent, and I solved for y. We typed that in decimals, and decimals gave me a really big number, 419.55. So decimals gave me a really big number, but that's okay. So this is the length of this section from here to here. So what I have highlighted in the red. Now let's go through, use a similar process to find this missing length here. Then I can add both of those together. So let's see what I can do over here. Say I use this missing angle here. That's 55 degrees. It looks like, again, I could do a tangent. So I'm going to set up a tangent. So I am going to write over here. So the tangent of 55 is going to be equal to my opposite side. This is 55. Go directly across. That's my opposite. So that's 500 divided by my adjacent side, which is z. So tangent is opposite over adjacent. Now I'm going to solve this for z. So multiply both sides. And divide. So that's going to give me z equals 500 divided by the tangent of 55. And let me start up there a little bit. So all I did was solve the equation. So we've been doing a lot of this over the past couple of days. I multiply both sides by z. The opposite of multiplying is to divide. So I typed this into Desmos, and it gave me 350.10. Now we are about 99% done with the problem. This problem wants us to find the whole entire length. We got this section in the red. We got this section in the green. We need to add these two pieces together and we will be in business. So add these two pieces together and our final answer will be 769.65. So I added these two pieces together. Let's write that note. Add together. And my final answer is 769.65.